All right, before we move on with more about 4.2, I want to tell you guys what's the reason behind this particular lesson. And here are some of the core standards. Um, so it's talking about using units as a way to understand problems and guide the solution of multi-step problems, and choosing and interpreting units consistently in formulas. So we're going to be talking a lot about units in this particular lesson. Um, Another standard is about define appropriate quantities for the purpose of descriptive modeling. So we're going to be thinking a little bit about what numbers would make sense. And then this one is a big algebra idea. Rearrange formulas to highlight a quantity of interest using the same reasoning as in solving equations. Another thing that's called is manipulating equations. They refer to it as manipulating equations. And sometimes that's also called isolating a variable. So an example of this that you may have come across in a science class is that distance, this is a formula used a lot in science and math, distance traveled is equal to the rate of travel multiplied by the amount of time. And you write that like this. Usually they use a capital D, I don't know why, equals rate times time. And this is only three little variables, but you can get a lot of information out of it. For example, if you know your distance is 100 miles, and you know your rate is 50 miles per hour, then you can figure out the amount of time it takes you to go that far. One of the ways you could do it is by solving this in terms of t, or manipulating this. And you would end up saying, okay, well, I know that this is rate times time, so if I want time to be isolated, I have to divide by rate. So I'd end up with the distance divided by the rate is equal to the time. 100 divided by 50 is 2. So it would take 2 hours to go 100 miles. You could have done that in your head, but if you had some different sort of thing going on here with decimals and stuff like that, and you wanted to use a calculator to do it, it'd be very handy to know how to do this. Okay? So this is using what you already know about math in a different way. Okay? So that's the point of this lesson. One of the points of this lesson. All right, so we're thinking about units as a way to help us understand things. And so go back to our chart. And let's just say what after our discussion, we'll come up with our final answers. And let's just do it like this, because I don't want to write in my book. I'll line up that one. That's not going to line up anyway. Okay, so the number of students that buy lunch in the salad line. We could say you're measuring students. And that's the same for the sandwich line and the pizza line. You could also have said people or kids. Okay, number of food servers in the cafeteria. Well, we could say people. We could have said people for all of them, but there's a difference maybe in what you care about the students coming in and the servers. So let's say we're measuring that in servers, or you might say adults. Again, we're thinking about elementary school here. Number of minutes it takes to serve lunch to all students. Okay, so one good answer there would be we're measuring or counting minutes. Oops, sorry, M-I-N-U-T-E-S, minutes. Number of classes in the school. So we're not counting individual kids, we're counting the classes. So let's say we're counting classes. right? Miss A's class, Miss B class, Mr. C's class, etc. Okay, now price per lunch. Now this is interesting because this is a kind of units where you have two parts because it says per here. And we're going to have more of those as we go along here. So price is measured in something like dollars, could be cents. So dollars per, we use a slash for that sometimes, or sometimes we write it like this. I'm going to write it both ways so you guys see. All right, dollars per lunch. Could also say dollars per student. It would also make sense. All right, and I'll write that the different way. Dollars per student. Okay, that's very hard to fit in that little space. So that's why using the slash can be helpful. But maybe over to the side, you could write it this way as well. So you think about, and you have back in your notes when it's time for the test, the two different ways to write this, okay? All right. So let's read the next part, and then you guys are going to work on it. Elvira, let's get this where we can see it. So now we're going to add some different things here. This is talking about A. Elvira has written the following equation to describe a cafeteria relationship that seems meaningful to her. She has introduced a new variable A to describe this relationship. Okay, this is meaningful to her, not necessarily you. This could happen when you're doing work for a boss who is interested in this relationship and you're not. You still have to do the work. So this is a real life example here. I personally am not very interested in this, but that's okay. I can still do it. So her variable A, she's adding S. I'm going to move this so we can see what these things are. Good. She's adding S plus W plus P. So it's the students that buy lunch in the salad line, the sandwich line, and the pizza line. And she's dividing all of that by C, the number of classes in the school. So our first job, number one, what does A represent in terms of the school and the cafeteria? Record this information in the table above. So this is a time for you to talk to your partner, talk to other people. What does it represent? What would it mean to add the number of students that buy lunch in the salad line and in the sandwich line and in the pizza line, and to divide it by the number of classes in the school? Okay, can you think of what that would mean?